This is the third to last video in the teaching series of contingencies in actuarial mathematics. I'm covering profit testing in this video, and then in the subsequent two videos I'll cover the reserving aspects of profit testing, which is technically the last bit of information that needs to be portrayed, and then the final video is going to be an application of these last three sections, these last three videos. So that being the unit linked and accumulating with profit contracts, profit testing, and reserving aspects of profit testing, all in one holistic big question that kind of tests all the application of the theory. So all the number side of it, because these last three videos have been all theory. Okay, so let's get on to profit testing then. So just to use a conventional whole life assurance as an example, this is what the expected profit from a particular year would look like. Okay, and I'm going to go and run through each entry in this long line here and try and show you what exactly is going on. And then I also want to say before I do that, that one thing to note about expected profit in a given year is that it is the expected profit per person or per policy holder, or per policy rather, in force at the beginning of the year, and it's expressed in the time value of money at the end of that year. Okay, so it's the expected profit from year t to t plus 1 will be the expected profit at time t plus 1, but for the policy holders that began that year. Okay, so for the number of policies that were in force at the beginning of the year. Okay, which kind of makes sense to us because the expected profit from a year will only emerge at the end of that year. And then since it's an expected profit from that year, we have to consider all the policies that happened in that year, the policies that were in force at least at some point within that year. And so we have to start at the beginning of that year. Okay, so its expected profit in a given year will always be the time value of money at the end of the year, and then the number of policies that were in force at the beginning of the year. That's what it'll be in terms of. Okay, so let's turn our attention then to this line here for conventional whole life assurance, the expected profit in year t to t plus 1. Okay, so at the beginning of this year, we receive a premium from the policyholder, this is P here, and we pay out renewal expenses, or maybe not pay out, but we incur renewal expenses. So this P minus E is that net flow, the premium less the renewal expenses. And since our expected profit emerges at the end of the year, we got to take all the cash flows to the end of the year. Okay, and P minus E will happen for every policyholder. So here there's an implicit times by 1. Okay, and the reason I'm timesing by 1 is because the probability of this for each policyholder at the beginning of the year is essentially 1. Okay, so I'm going to receive a premium from every policyholder that was in force at the start of the year, and there'll be a renewal expense for every one of those policyholders as well. And then I future value that to the end of year, 2 times t plus 1. Okay, now in this year, policyholders may die. Okay, and this term here is accounting for that. So there's no time value of money here. I'm not multiplying by a 1 plus I to future value it, because I'm assuming that the sum assureds are paid at the end of year of death. Okay, so here is the sum assured amount that gets paid at time t plus 1 for the lives that died during the year. And the lives that died during the year, this happens with this probability. So this is the dependent probability of a life being removed from the active state, which is the healthy state or the state of being a policyholder, being removed by the decrement of death. And then while they are aged, x plus t. Okay, so x plus t because they were aged x, select here, that's why I have those brackets there, at the start of the policy at time 0, but now at the start of the year, they are t years into the policy, and so they're now aged x plus t. Okay, so this is the dependent death probability. Here's the sum assured. So per policy in force, this is the expected sum assured per policy, okay, in force at the beginning of the year. And that makes sense, beginning of the year, because that's the age at the beginning of the year. All right, then this here is the dependent probability that a life aged X plus T will be removed from the active state by the force of decrement W, okay, or by the decrement W. And this decrement W represents withdrawal, so withdrawal from the policy. And if someone withdraws from a policy, they'll be paid a surrender value, and that's this SV here. So this is not to be mistaken with a sum assured value S times by a reserve V, as this is here and as this is here with this S and this V. This here, this SV at T plus 1 indexed, is the surrender value that will be paid to lives that withdraw from the policy in this year T to T plus 1. Okay, so that's also considered an outflow in the same way that this sum assured paid on death is also considered an outflow. Okay, so these both happen at the end of the year, and so we don't have any interest taken into account. Now, this bracket here, this big bracket here, is to represent the change in reserves. So in any given year, I have reserves for my policies. Now, at the end of each year, or at the beginning of each year, depending on how you look at it, I have to now change my level of reserves, because the level of reserves that were required in one year is not necessarily the same as what should be required in the next year. Okay, and so given that they're not the same, I have to change these reserves, which means this here is going to be an outflow representing an increase in reserves. So if my reserves increase, then this inside this bracket will be positive, and so I'll have to subtract that from the profit, okay, from the expected profit in that year. So I take out from the profits the amount that I need to increase the reserves by. Okay, so let's understand then why this should represent an increase in reserves. Well, let's think about this. This here is the reserves required at time T plus 1, at the end of this year, or at the beginning of the next year. And I multiply that by the factor S. Now, this is just dependent. S times by T plus 1V could have just been written as T plus 1V, depending on whether T plus 1V is a factor and it's already been multiplied by S or not. So in this particular line here that's written in white, I'm assuming that I haven't already multiplied it by S. But you just have to make sure that if this has already been multiplied by S, in other words, if it's not some small number around 1 or smaller than 1, then you should multiply it by S. So if it is around that, if it's a small number, you should multiply it by S. But if it is a large number, then it's already been multiplied by S. So you don't have to multiply it by S again, like would be done here, because it's already in there. Okay, so you just have to be careful about that. Now, this first term in this brackets represents the expected reserve that needs to be held at the end of the year, given I'm now standing at time T, or at the beginning of the year. Okay, so I'm going to need this much in reserves. And the reason why I multiply it by the dependent probability of a policy still being in force at time T, T plus 1, is because I only hold reserves for the policies that are still in force. So if a policy is not in force, then I'm not going to hold reserves for that policy anymore. Okay, so this is only reserves for policies that are still in force. And so I must take into account the probability that a policy will still be in force at time T plus 1. Okay, and then this here, this term, is the reserves at the beginning of the year. So here, I hold these reserves, S times by TV. I hold that reserve for each and every policy. And since my expected profit is in terms of policies in force at the beginning of the year, I don't multiply this by a probability, because there's an implicit multiplication by 1 there, because every policy has this reserve at the start of the year. Okay, then I must future value it to the end of the year with 1 plus I. Okay, so This symbolizes the difference in reserves. So the reserves at the end of the year minus the reserves at the beginning of the year is how much I need to increase them by. And if I have to increase them, then this is going to be a subtraction from my profit. Okay, and you can also think of this here, instead of it just being in order to calculate the difference, you can say, okay, well, or rather this is just basically another way to think of the difference. You say, I'm starting with this, and so if you were to distribute this negative in, this becomes a positive. So I'm actually adding the reserves at the beginning of the year and then subtracting the reserves at the end of the year. So you can think of it that way as well, instead of just subtracting the increase, which is essentially the same thing as adding at the beginning and subtracting at the end. So that's essentially the same thing, just two different ways of thinking about it. Okay, now, what is the reason for profit testing unitized with profit contracts in particular? Okay, so in general, the reason for profit testing is because we need to ensure that our policies are viable. This is a way of monitoring the experience, okay? So we need to make sure our policies are viable. We might be, so it's not just about monitoring the experience, it's also about setting our premiums in advance, setting valuations. We profit test at multiple points along the contract's timeline, and the reason we do this is to make sure that we're not bringing into force a book of policies that is not going to be profitable for the business. So profit testing is important, and we do this as we move throughout the stages of the maturation of this contract. Okay, so bringing it into existence and then as it matures. Okay, so why then must be profit test for this in particular? Well, the reason why I'm asking this question is because unitized with profit contracts are essentially designed in such a way that we're supposed to distribute all of the profits back to the policyholder. Okay, so why then is there a need for profit testing if we're just going to give all the profits back to the policyholder? Well, the reason is because we're profit testing not on the units, but we're profit testing on the non-unit fund in this particular instance. Now, not necessarily a unit-linked contract, so non-unit fund is maybe not the best terminology, but we are profit testing the non-unit profits. Okay, so by projecting the future non-unit profits, the insurer can check that its charges are going to be on track to cover the outgoes for this policy. And so it's important to still profit test to make sure that we can cover all the costs that we are going to incur as an insurer. And then we are going to distribute then all the profits from the investments back to the policyholder. So we make that assumption prudently. The reason why we make that assumption is because we might not necessarily end up distributing all the profits back. Now remember, an accumulating with profit contract, there's less transparency with the policyholder in that there's smoothing of returns, and the policyholder, the insurer, may withhold returns in certain years in order to fund them in later years, and also to fund expenses and profits for themselves. Okay, but we now are going to assume that all profit is going to be distributed to the policyholder as a prudent scenario, because it might not necessarily be the case, but we're going to assume that all of the profits will be from the investments will be distributed back to the policyholder, and this allows us to go through the profit testing process with a prudent perspective to make sure that we actually can cover all the outgoes, that all the charges can actually cover all the outgoes that we're going to have to make. Okay, so what is the profit vector? So the profit vector is the vector of balancing items in the projected revenue accounts for each policy year. So it's the expected profit at the end of each policy year per policy in force at the beginning of that policy year. So this is the same way that I described this expected profit here. So this expected profit, I described it as being the profit from a policy within a given year at the end of that year in terms of the time value of money, but per policy in force at the beginning of the year. Okay, and now the profit vector then is just these expected profits per all of the years in a vector form. So if in year 1 I have a loss, then my first entry in my profit vector will be that loss. If in the final year I have a profit, say, then that amount of the profit will be the final entry in this profit vector. Okay, so what is then the profit signature? So, okay, yeah, so this profit here with this T, it's supposed to be a subscript here on the right hand side. This is actually the expected profit at time T. Now, PRO there, that would be the profit vector. Now, when I index it with the T, then it's the entry, the Tth entry from the profit vector. And likewise, PS is the profit signature. It's also a vector. And then when I index it with the T, then it's the profit signature from that year. Okay. So what is a profit signature? The profit signature is the vector of expected profits per policy issued. Okay, so this is per policy issued now. It's not per policy in force at the beginning of a policy year. It's in the beginning of the policies in general. So it's at issue date. So it's the expected profits per all the policies. So what this means then is in every given year, in order to move from profit vector to profit signature, what we have to do is we have to discount in terms of probability. So we have to take into account the fact that the life has to survive, or not just survive, but has to still be in force, because remember they can withdraw as well. But they have to still be in force from the beginning of the policy up until the beginning of that year. Okay, so if I look at my policy like this is time 0, this is time t minus 1, and this is time t. Now my profit vector, PRO, t there. So this is the Tth entry in the profit vector. This is the profit that arises at that particular point in time, but it's per policy in force at time t minus 1. Now PST is per policy, the expected profit in this year, okay, but per policy in force here, okay. So that means I have to take into account the probability that the policy will still be in force all the way from time 0 to t minus 1. So in order to move from profit vector to profit signature, what we have to do is this. So we have the profit signature at time t is going to be equal to t minus 1 APX times by the profit vector. Okay, now what this does, this here is the profit vector, and this just takes into account this time interval that they have to survive as well. Okay, so that's the only difference there between the profit signature and profit vector. So it's still in terms of time value of money, it's still sitting at time t, but in terms of policies, in terms of the number of policies that are in force, and in terms of expected profits, then it's at time 0. Okay, so let me erase this. All right, now we have summary measures of profit. Okay, so obviously we have this profit vector that sits in absolute terms, the amount of profit, and we have this profit signature as well. Now, there are other ways that we can measure profit. Now, one of the ways that we can do that is with the net present value. So the net present value is this. So it's the sum from t equals 1 to infinity, or until the end of the contract, this here is the risk discount rate, or the cost, so the risk discount rate, and the risk discount rate is equal to the cost of capital plus a risk premium. Okay, so we use the risk discount rate to present value profits in this net present value here. And the reason why we're using a risk discount rate is because we have to take into account that little risk premium as well as just the cost of the capital that we have. Okay, so we discount profits using the risk discount rate. So here we have T there, that should be a T, and then the profit signature at time T. So profit signature is per policy in force at the beginning, and then now we just have to discount in terms of time value of money, because in terms of probabilities or in terms of expected policies, we're actually sitting at time 0 already, okay, in terms of this profit signature, yeah, but not in terms of the time value of money. So we have to discount every entry in our profit signature and then sum all of those up to get our net present value. Okay, and then the net present value serves as a summary measure for our profit overall. Now, profit signature and profit vector aren't necessarily all that helpful because we have a vector of values, and so it's difficult to interpret as it is. So we convert it into this net present value, which is one summary number of the profit. Okay, then another measure is the profit margin. So what the profit margin is, this is equal to the net present value over the expected present value of the premiums. Okay, so you think of that then as the profit over the revenue or over the income. Okay, and so this then we can further, actually let me just write it over here. This is equal to the sum 1 plus ID, now when ID is our risk discount rate. That's a profit signature. And then my expected present value of premiums. Okay, so this numerator, nothing has changed since I described the net present value there. Now, the denominator, this is, again, sum from 1 to infinity, 1 plus ID. This is my risk discount rate again, negative T. And now it's not just my premium at time T, but also multiplied by T minus 1 APX. Okay, because they must survive until the time that they're going to pay that premium. So each premium has a corresponding probability of it actually being paid, and that's this probability over here. Okay, so since this was expected present value, not just present value, we also multiply by here. Now that's a very easy mistake to make, given that over here you're just discounting in terms of the time value of money, but here you actually also have to discount in terms of probability. Okay, so this is the profit margin then. And this will often stand at the end of a profit testing calculation. We might have to tabulate a lot of values, calculate the profit vector, then go from profit vector to profit signature. And then we have to go and calculate the net present value from the profit signature and the expected present value of premiums, and then put those together to get our profit margin. And then we might have to have a comment about that or something. And remember, the profit margin is expressed as a percentage. Okay, so if the number that you get out is 0.8, then you say profit margin 80%. Okay. Now, the internal rate of return is another measure of profit. And what this is it's the interest rate that satisfies this equation. The net present value equal to 0. Okay, so here the net present value was calculated using the risk discount rate. Now, if I swap that risk discount rate out for the internal rate of return, then the internal rate of return would be the interest rate at which my net present value equals 0. Okay, so you might need to do linear interpolation for this question in order to calculate that. All right, but that should be known from financial mathematics, and I'm going to assume if you're doing contingencies, you would have done financial maths and you'll know how to do that. Okay, All right, and the internal rate of return is only defined if the first profit flow is negative and the rest of them are positive. Now, the reason why this is so is because, or that's called like a single financing period, and the reason why this is so is because if it's not, then just think in terms of maths. If you only have positive values, then your line, your net present value line, will never intersect your x-axis or your horizontal axis. And so this equation will never have a solution. Okay, so we have to have one of them being negative in order to end up getting a solution out of that. All right, now what is a profit criterion and how do we choose it? So a profit criterion is something that the insurance company will use in order to make sure that this contract is something that's worthwhile to them, and this profit criterion is going to be an objective. It's the objective specified for the expected level of profit, and that's called the profit criterion. Now, the insurance company will set this profit criterion as an objective to try and meet, okay? And in pricing and in doing valuation and all these other things that they might have to do, they will take into account this profit criterion and they'll play around with the premiums and assumptions and make sure that everything's fair and working well, such that this profit criterion is met. So they want to expect to meet this profit criterion. Okay. Now, how do we choose the profit criterion then? Well, if there's something that's particularly of interest to the insurance company, let's say that be the productivity bonus of a sales force, then they might want to maximize the profit with respect to the sales force when the sales force maximizes its income. Okay, then you might have the profit criterion being where the net present value must be a certain percentage of your initial sales commission, and that stands as a valid profit criterion. You might have it linked to another type of your business. So if you put a particular emphasis on a particular part of the process, then you might want to make your profit criterion linked very closely to that. Or if you've identified that the major driver of profits in this particular contract is actually going to be just the pricing of it, okay? And then what's important to me is, I would say, profit margin, because profit margin incorporates those premiums. Okay, so that's just something that the insurance company would set, something that's important to them with respect to the profit or drives profit, and so they'll set the profit criterion with respect to that. Now, this last point, the steps of profit criterion, I wrote this as a quick list to remind myself that I don't want to go into too much depth here, and I don't want to go into too much depth because this is something that's really unlikely to be a question in one of your tests or exams. And so I don't want to spend a lot of time on it from that perspective. In fact, I was considering not doing it, but I still want to do it because I think it aids understanding, which is important for when you eventually work, and also important to understand the context in which everything is working. Okay, so the steps of profit testing. First, the first thing needs to be decided is the product structure. Now, once the product structure is decided, then you can build models to project cash flows given this product structure. Then you will choose specimen policies. What specimen policies are, this is it's like an avatar. This is the target policy. So your average policy, your expected, if you were to average out all your policy holders, then it would look like this particular person, and that's your specimen policy. Okay, and you could have a different range of specimen policies to try and assess the different markets that this product is going to hit and how they all interact. Okay, so you choose specimen policies. This is like with respect to age, sex, the level of cover, etc. So choose these specimen policies. So remember now, you have the product structure. This is product design. Then you have built the model to project the cash flows, and you've chosen these important hit points, okay, these specimen policies. Now you decide on a risk discount rate that's realistic but also prudent, and a profit criterion. Then you can choose a basis. And the basis is probably going to be a best estimate of experience, given that we're doing profit testing. If you were doing valuation, okay, or you were trying to reserve, then you might take a pessimistic view instead of a best estimate basis. But since we're profit testing, we want to get a realistic look at this, so we can probably use a best estimate of experience as our basis. Then we have to decide on a first draft of premiums or charges, and we'll profit test with respect to those specimen policies that we chose for these particular premiums. Okay. Then we'll vary those premiums and charges until our profit criterion is met, that profit criterion that we specified at the beginning as well. And then we have to also make sure that the premiums are going to be acceptable in the market, and it's not just that the profit criterion is met but we don't have a marketable policy. We need this policy to also be marketable and the premiums to be marketable. So we have to check that the profit criterion is met and the premiums are marketable. If none of that happens and this policy is looking like it's not going to be marketable, and in order to bring it to market it's going to be way too expensive, no one's going to buy it, then you'd probably scrap it and you'd look for a different structure, or you might look to make it cheaper. You might take away some of the benefits that you initially wanted to include in the product design. At the beginning, you might go back to the decide on the product structure step. It depends on how it all working out. Okay, so but let's say then you've found premiums and charges that meet your profit criterion and that are acceptable in the market. Now we're going to sensitivity test by varying our key parameters, so our key assumptions here, to check that our product design is sufficiently resilient to adverse changes in future experience. So this now, we vary our assumptions, all these different moving parts, these variables in our model, in our cash flow model, and we see how the profit responds to this. Okay, we see how the final profit criterion is responding to all of this. And if there's massive shifts in it or in other parts of our model, then that's not a good sign. We want to sensitivity test this, but maybe if it's shifting for a assumption change that's extremely unlikely, we might be able to bear that. But these are things we take into account. So we sensitivity test, we try and understand the uncertainty involved in this, how it interacts with uncertainty, how our model interacts with uncertainty, and how we are going to expect this product to interact with uncertainty once it's put into the real world. Okay, so we don't want to find out that we have this premium that meets the profit criterion that's acceptable to the market, but now one slight change in the interest rates and everything goes to a disaster. We don't want that case. Okay, so that's why we sensitivity test. And then we'll keep varying premiums and features if necessary until we have finalized the product design and our premium meets the profitability criterion. Our product design meets this profitability criterion. It's marketable and it's resilient to adverse future experience. So that resilient to adverse future experience we assess through those sensitivity tests. Okay, so that's it for this video. I hope you found it interesting and I hope you derived some value from it, and I'll see you in the next video for reserving aspects of profit testing.